Good morning. It's September 24th, and this is your daily brief in science. Here's everything you need to know. Researchers are making strides in the quest for early diagnosis of Alzheimer's disease by investigating blood-based biomarkers, specifically plasma microRNAs or mRNAs. This approach offers a less invasive and more accessible method for identifying the disease before clinical symptoms manifest. The potential of these microRNAs lies in their ability to serve as biomarkers years ahead of Alzheimer's onset, paving the way for early intervention and preventive strategies. Recent studies indicate that a combination of plasma microRNA evaluation with neuropsychological tests can effectively predict cognitive decline in older adults. Notably, the expression of MIR197-3P was significantly lower in Alzheimer's patients compared to healthy individuals, highlighting its potential as a biomarker for the disease. Given that there is currently no cure for Alzheimer's and existing treatments only provide temporary symptom relief, early detection is crucial. Alzheimer's disease is marked by the accumulation of amyloid beta plaques and neurofibrillary tangles composed of hyperphosphorylated tau protein, emphasizing the need for timely diagnosis. In related research, a study involving 73 multiple sclerosis patients underscored the critical role of T cells in disease progression, while exploring exosomes from mesenchymal stem cells as a potential treatment for MS. The characterization of isolated extracellular vesicles confirmed their purity and presence of typical markers, reinforcing their validity for biomarker discovery. Additionally, the research has evaluated specific microRNAs and extracellular vesicles from blood samples of papillary thyroid carcinoma patients, further supporting the role of microRNAs as non-invasive biomarkers. As this field advances, there is a growing need for policies to safeguard patients with positive biomarker results from potential adverse effects on their insurance or disability rights. A recent scientific breakthrough has doubled the number of known geoglyphs in the Nazca Desert of southern Peru. Researchers have discovered and mapped 303 new geoglyphs using artificial intelligence, bringing the total count to approximately 730. This innovative research was a collaborative effort involving Yamagata University, University Paris, and IBM. By employing AI, the team analyzed vast amounts of geospatial images, significantly improving the speed and accuracy of geoglyph identification compared to traditional methods. The AI model was able to identify these new formations within just 6 months of fieldwork. Among the newly discovered geoglyphs are smaller and older figures, including a notable 72-foot-long killer whale holding a knife. Many of these glyphs are believed to be connected to a pilgrimage to Cahuachi, a ceremonial center that overlooks the designs. The study also distinguishes between relief-type and line-type geoglyphs, discussing their differences in style, size, motifs, and potential communal ritual uses. Despite these advancements, the true purpose of the Nazca lines remains elusive, with theories suggesting they may have served as astronomical observatories or calendars. Created between 500 BC and 500 AD, these ancient geoglyphs span several hundred square kilometers, offering insights into the cultures and beliefs of early civilizations. The AI analysis not only aids in identifying geoglyphs within the Nazca Lines World Heritage Site, but also holds promise for discovering additional formations that may be threatened by agricultural and urban development. Looking to the future, researchers estimate that around 250 more potential geoglyphs could be revealed, further expanding our understanding of this ancient art form. A new model is making waves in the fight against lung cancer. Researchers have developed MTNet, a multitask network designed to simultaneously segment and classify pulmonary nodules, a critical step in early diagnosis. MTNet employs the efficient UNET-VT architecture, which merges the global context capabilities of vision transformers with the precise localization strengths of UNET. This combination enhances the model's effectiveness in tumor segmentation, which is crucial given the prevalence of pulmonary nodules in chest CT scans. Experimental results from the LIDC-IDRI dataset reveal that MTNet achieves a dice similarity coefficient of 83.2% for segmentation and an accuracy of 91.9% for classification. These results position MTNet competitively against existing state-of-the-art methods in the field. The architecture of MTNet includes 3 subnetworks: coarse segnet for initial segmentation, fine segnet for detailed segmentation, and classnet for classification. To further improve segmentation accuracy, the model utilizes a hybrid loss function that combines dice loss and rank loss, particularly enhancing performance at nodule boundaries. Additionally, an ANOVA analysis was conducted to evaluate the impact of various factors on segmentation accuracy, with findings indicating that a higher number of training epochs leads to improved results. Given that pulmonary nodules are detected in approximately 30% of chest CT scans, and that the risk of malignancy increases with nodule size, effective segmentation techniques are essential for early diagnosis. Lung cancer remains the leading cause of cancer-related deaths, highlighting the urgent need for advanced early diagnosis methods. Computer-aided diagnosis systems are vital for improving diagnostic accuracy in lung cancer detection, especially considering the high mortality rates associated with the disease. The study underscores the advantages of deep learning techniques over traditional methods, showcasing their effectiveness in medical image analysis. Researchers at the University of Zurich have made significant strides in DNA editing, focusing on TNPB, a smaller ancestor of the CRISPR-Cas system. TNPB, which is derived from the radiation-resistant bacterium Deinococcus radiodurans, has historically struggled with efficiency in genome editing due to its stringent DNA binding requirements. Under the leadership of Gerald Schwank, the research team engineered TNPB to achieve a remarkable 4.4-fold increase in its DNA modification efficiency compared to the original protein. The team optimized TNPB to enhance its ability to reach the nucleus and broaden its targeting capabilities across various DNA sequences. By utilizing adeno-associated viral vectors for delivery, they successfully transported TNPB into mouse cells, benefiting from its smaller size, which allows for efficient packaging into a single virus particle. In extensive testing across 10,211 target sites, the optimized TNPB demonstrated editing efficiencies of up to 75.3% in mouse livers and 65.9% in mouse brains. Additionally, this research explored TNPB's potential in treating familial hypercholesterolemia, a genetic disorder affecting 31 million people globally. The team successfully reduced cholesterol levels in treated mice by nearly 80%. The ultimate goal is to develop similar gene editing therapies for human patients suffering from high cholesterol-related diseases. The findings of this study, which highlight TNPB's potential as a more efficient genome editing tool, were published in the journal Nature Methods on September 23, 2024. CRISPR-Cas systems, originally a bacterial defense mechanism, have transformed genetic engineering, paving the way for precise genetic editing in medicine and biotechnology. The success of TNPB in reducing cholesterol levels in mice raises hopes for adapting this approach for human patients in the future. Furthermore, by developing an AI model to predict TNPB's editing efficiencies, the researchers are laying the groundwork for more targeted and effective gene editing applications. A recent study has made significant strides in understanding the genetic factors that increase the deadliness of cholera. Published on September 23, 2024 in Nature Communications, this research sheds light on the Vibrio cholerae bacteria, which is responsible for cholera outbreaks worldwide. Led by Professor Tanya Dottorini from the University of Nottingham, the study involved collaboration with various health institutions in Bangladesh, including the Institute of Epidemiology, Disease Control, and Research. This partnership underscores the importance of integrating local expertise with advanced scientific methods. The research, funded by Research England, the Global Challenges Research Fund, and the Medical Research Council, analyzed bacterial samples collected from cholera patients in Bangladesh between 2015 and 2021. The team identified unique genetic traits linked to the severity of the cholera outbreak in 2022. Key findings reveal a connection between the bacteria's genetic composition and its capacity to thrive in the human gut, enhancing its resilience and virulence. The identified genetic traits are associated with severe cholera symptoms, such as prolonged diarrhea, intense abdominal pain, vomiting, and dehydration, which can ultimately lead to death. Cholera poses a significant global health threat, with around 4 million cases and 143,000 deaths reported annually. Bangladesh is particularly vulnerable, with approximately 66 million people at risk. Professor Dotterini emphasized that understanding these genetic factors could pave the way for more effective treatments and interventions, potentially saving lives both in Bangladesh and globally. This innovative study marks a crucial advancement in cholera research, aiming to enhance public health responses and prevent future outbreaks through targeted strategies. Researchers employed advanced techniques, including machine learning, genomics, and 3D structural analysis, to delve into the genetic traits of Vibrio cholerae. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.